Welcome, and thank you all for joining us today for our Monash Prato Dialogue Distinguished Lecture Series in Artificial Intelligence. I'm Professor Joanna Batstone, the Director of the Monash Data Futures Institute at Monash University, and I will be your host and moderator. Before we begin, I wish to acknowledge the traditional owners of the lands on which we're gathered today. I pay my respects to their elders, past and present. Please also join us in the conversation on social media by following us on Twitter at MonashDFI and by using the hashtag #MonashPratoDialogue. The Monash Data Futures Institute is the largest interdisciplinary community of AI and data science thought leaders in Asia Pacific, and we're committed to excellence and shaping the future of the field. Within our institute, the focus areas include the use of data-driven AI across research in governance and policy, sustainable development, and health sciences. This new Monash Prato Dialogue Distinguished Lecture Series aims to explore the evolving impact of data science and AI in society by fostering a global dialogue. The series takes its name from Monash University's center in Prato, Italy, that represents an international base for research, education, intellectual and cultural exchanges, and enables us to bring people together to meet, learn, and collaborate with peers and colleagues from around the world. You've joined us today for the fourth lecture in this series, where we are pleased to host Professor Rayid Ghani. Professor Ghani is a distinguished career professor in machine learning and public policy at Carnegie Mellon University in Pittsburgh, United States. He's a reformed computer scientist and aspiring social scientist, and he's mostly focused on increasing the use of large-scale AI, machine learning, and data science in solving large public policy and social challenges in a fair and equitable manner. Before joining CMU, Professor Ghani was the founding director of the Center for Data Science and Public Policy and a senior fellow at the Harris School of Public Policy at the University of Chicago. He was also the chief scientist of the Obama 2012 election campaign, where he focused on analytics, technology, and data to identify voters, donors, and volunteers. In today's Monash Prato Dialogue lecture, Professor Ghani will highlight opportunities as well as challenges that we need to tackle in order to have social and policy impact in a fair and equitable manner. That's all from me. Over to you now, Professor Ghani, and thank you for joining us today.
Thank you, Joanna, and thanks for inviting me for this lecture. I wish we were doing this in person. Much better place. And Australia is in fact my favorite food and coffee country in the world, so it's always a pleasure to be there. I'm not going to get into the what coffee is better, Melbourne or Sydney, since we have too many probably Clayton people here, so that might not go very well given my preferences for the other place. That being said, thanks for having me here. I thought what I could do is share some of my experiences working on a few different projects over the last few years with different government agencies and nonprofits, where the goal was to kind of solve a very specific problem that our agency was facing. And so I'll kind of give you a high-level idea of some of these projects, what we did, and some of the outcomes, but then switch to sort of thinking about, when we're thinking about solving a lot of societal problems, we end up facing very critical questions around the values we want these systems that we're building to have. Do we want them to care about efficiency or equity or efficiency, sort of different types of goals? And the systems we develop end up implicitly or explicitly embedding those values and goals in them. So I'll kind of spend a little bit more time of sort of how we think about that, how we embed those in these systems, and then how they live in kind of a human-machine collaborative world where they're interacting with people to help make decisions, and how they impact communities and societies, and what their role should be, ideally in designing these systems. So I'm going to share some slides, mostly so that people don't fall asleep. Now it's morning there, so it shouldn't be that bad, but still. So I'll start with some work that we started several years back. This was some work in the US around criminal justice. As a lot of people are aware, criminal justice systems in a lot of countries are fairly broken. US is much worse than many other places. These numbers are, so in the US you have sort of local jails, which are city and county level, and then there are prisons that are typically larger, federal or state level. So these are numbers just for jail. In a typical year, about 11 million people go through jail. And yes, it's expensive, but the really horrible things are the last three numbers, right? 2/3 of the people going through jail suffer from mental health issues, substance abuse disorders, chronic health problems. And the worst of it is they keep cycling through. So they get in there, they get out, but because of these underlying causes, they get back in and they just keep cycling. So this county, which is in the middle of the US in Kansas, came to us and said, look, we have a high rate of reincarceration. And we think a lot of the underlying causes are because of mental health issues. And we have some resources to allocate towards sort of proactively providing mental health services to people. But what we don't know is who should we prioritize for those resources. We have, for now, on a trial basis, resources to help a few hundred people every month. How do we select those few hundred so that it reduces jail reincarceration? So what we ended up doing was we started off looking at what information do we have about these individuals who are cycling through, and got access to data from the criminal justice system, from the health system, the mental health services, emergency rooms, because that's where a lot of people were going through, and put it all together to get a picture of what's going, what is happening with these individuals. Second piece was to try to figure out which of those people are at risk of reincarceration. So we built a system to predict risk of reincarceration. Now, at this point, some of your alarm bells should be going off. Right? You're predicting they're going to commit a crime, and that doesn't seem right. Well, there's a lot of sort of underlying issues that we have to deal with. Right, a lot of ethical issues, a lot of contractual issues of who can use this information, who's involved in building these systems. So in this case, the idea was that if we can identify people who are high risk of going to jail, can we proactively send mental health services? And so this data is not going to go to the police department, to any criminal justice organization, and will only be used by the mental health team to proactively provide these types of services. So that was kind of step one, is trying to predict who are the people high risk. The next thing was to look at will providing them mental health services reduce their risk of going to jail, right? Because we can keep predicting who's going to go to jail and then watch them go to jail unless we think we can change their behavior and change their outcome. And so we looked at their historical data on consumption of mental health services, and kind of for an initial analysis, use that as a proxy for let's say they have some mental health needs. So we found that we could accurately predict who's going to go to jail again. But then the next question we wanted to ask was, okay, will connecting the people we can accurately predict at risk of recidivism and having mental health needs historically, will connecting them with these mental health services, is that going to reduce their risk of recidivism? So we started a randomized controlled trial about 2.5 years ago, where we would give them this list to the mental health service team. They would provide those services, and then we get that data back. And that trial is not finished yet, because we're looking at kind of long-term outcomes, where we're so far, the early results we're seeing is that we're getting reduction in arrests, we're getting increased use of mental health services, and we're seeing direction that it is indeed lowering to some extent their mental health, their rate of recidivism. The second question we're looking at is, yes, overall it's effective, but are there certain people it's more effective for? Is there certain people it's leaving behind and not working for? So we can then work with the teams there to design programs that work for everyone. And so what we found is, looking at, again, some early results, is the people who were the highest risk, those were the people we ended up reducing their risk of recidivism the most. which was a little bit surprising to us, because often the people at the highest risk are the ones that are hardest to change outcomes for. So that was encouraging, but it's still, lots of caveats there. It's still kind of early, and that trial is still going on. So I'll continue with some other examples of these types of projects that we've been doing. This is a relatively old project, but this is in the US around lead poisoning, which is again an issue that's happening around the world, because of lead paint in homes, or presence of lead in paint for many years. Most older homes have lead paint in there, and that's fine as long as the paint is inside. But as homes get old and paint starts chipping, kids pick up lead dust, put it in their mouth, horrible things happen. And I think that the worst thing of all of those horrible things is that all of these things are irreversible. So once you've been exposed to lead, there's nothing you can do to fix it. So the only way to fix it is to prevent it. Except most government agencies in the US, at least, are very reactive. So what they do is they test kids for lead poisoning, and if they find a kid with lead poisoning, they then send health inspectors or home inspectors to check for lead hazards. And guess what? They find lead hazards 90% of the time, because how else did the kid get lead poisoning? So the de facto policy people use is using children as lead sensors to detect lead, because they're extremely accurate. It's horrible, but it's what we end up doing. And so this was a few years back again, when the Chicago Health Department came to us and said, we know we're being reactive. We know that's not the best approach, but we're doing it because we don't have resources to proactively fix every single home in the city. It's too expensive. How do we allocate those resources? Kind of very similar problem, to the previous one. We have limited resources. How do we allocate them so that it results in reducing rates of lead poisoning? And again, the process was very similar, right? Connecting different pieces of data about all the blood tests that have been done over the last 10, 15 years, with all the home inspections that were done, or any home information available around construction or reconstruction or rehabbing or anything else, to combine all that and take kids that are a month, 2 months, 3 months old before they're able to crawl and pick up lead dust. Take every kid in the city that's at that age and predict their risk of getting lead poisoning over the next few months. And the next sort of few months, the idea was that if we can predict 6 months early for a 3-month-old child, then it gives the department about 6 months to figure out, allocate resources for inspections, but more importantly, have the time available to actually fix and remediate those issues. Because it's not you press a button and a home gets fixed. It takes time to remediate those issues, whether it's replacing doors and windows or repainting. And so you wanted that early warning, early enough that something could be done. So that system is now deployed, and it's also working in hospital systems, where it's doing the same thing in a hospital system, which is, but doing it even earlier. So when a pregnant woman goes in for a checkup, it will run the same system and alert the health department and the doctor that the kid that's going to be born will have high risk of lead poisoning, so that they can plan even earlier and prevent, and reduce any risk or prevent any risk of lead poisoning. This is yet another depressing issue. A lot of countries have it. US has it particularly bad, and it's not isolated in a couple of places. It's pretty widespread across a lot of police departments in the US, which is misconduct. Police departments using excessive or unjustified use of force, and this work we've been doing for several years, and the initial idea was police departments have a system that they call early intervention systems. And what they do is they raise alerts when an officer is at risk of doing one of these horrible things, unjustified shootings, unjustified use of force, anything else that sort of we don't want them to do. Except it turns out nobody had bothered to evaluate or any of those systems. So we started with kind of working with first a state called North Carolina, which is in the east coast of the US, and in Charlotte, Mecklenburg city and county there. And our first step was really to evaluate that system. And it turns out it was mostly useless. It was flagging more than half of the police officers, making it totally unreliable, and nobody trusted it. Nobody, it had no credibility. And so, and it was kind of, the second thing was that not only was it useless, it wasn't really even giving early warning. So it was basically based on a handful of these thresholds. So if somebody has has had 3 uses of force in the last 6 months, or 6 complaints in the last 3 months, raise a flag. Well, that's not an early warning, it's a late warning. You can't really do much at that point except something punitive. And it's not really a preventative approach. So we took the same approach to sort of figure out, what do we know about these police officers with the police department, getting data about their history, about their demographics, about their HR and training and dispatches that they've been sent on and arrests they've made, their investigations, everything else, and use that to see, can we identify officers who are high risk of doing one of these things in the near future, so that we can then connect them, figure out what could possibly reduce that risk. Is it providing them with training? Is it providing them with counseling? We found, indicators like domestic abuse dispatches, domestic abuse cases, or the dispatches to suicide attempts made them high risk in certain cases. In that case, there might be, stress issues there, or it could be that this officer is really high risk of doing these types of things, and we need to change what kinds of people you bring in, and how you use these types of systems in hiring, in HR systems, and try to prevent this from the beginning. And so that system is again deployed in a few different police departments, and is being used to again provide this information to the department to then intervene. And I'll come back to sort of some of the issues that come up in these types of things, both technical as well as ethical issues that exist here. This is another project we've done in a few different schools systems in the US, as well as in some other countries, including El Salvador. And the idea, again, there is a lot of students who need extra support in order to graduate school on time, or high school, or go to college, or sustain, come back to school the next year. And often there are resources that exist to help them, but they're not matched with the right students who need them. And so the work that we've been doing here is seeing, can we accurately identify students who are high risk of one of these outcomes, and then try to figure out how do we connect them to these types of resources. And the challenge here is, it's not enough to be accurate in these types of systems. You have to be early enough that the intervention can be effective. So just like the lead poisoning case, if I don't have a few months to do the inspections and the remediation, then it doesn't really matter how accurate I can be in identifying them. Same here, like if I accurately identify who's at risk of not graduating the day before they don't graduate, well, that's too late. It's like, I can't do anything about it. And so what we're finding is that we're able to do that, at least in many cases, early enough. So 3 years, 4 years, enough that makes it feasible for teachers and schools to actually focus the resources on those students early enough to try to change their outcomes. This is a project that I don't have, we're kind of in the middle of, recently started in Mexico, and this is nothing to do with COVID. It's all the other vaccinations that kids are supposed to get, whether it's hepatitis or MMR or various other ones. There's a large number of children in Mexico that don't get vaccinated in time. Some of it because of supply issues, some of it because of access issues, some of it because of other behavioral reasons. And the governments they were working with wanted to figure out, can we again give them an early warning of which kids are likely to not get vaccinated on time, so that they could figure out different types of interventions, whether it's doing proactive outreach, or seeing if they're coming into the hospital for something else and it's close enough that they're eligible for the vaccine, might as well just give it to them then, or trying to make sure they have enough supply if they do come in for those types of things. So that's kind of ongoing project that we're in the middle of right now. And then there's a whole series of sort of, a lot of the projects I talked about before are these early warning systems, right? Where we're trying to sort of predict some bad event outcome happening for people, and then trying to prevent it through one of different interventions. A different class of projects that we we've been doing is really around sort of more inspections or audit projects, right? So this might be around some work in Chile around improving their workplace inspection program, where they have a few 100,000 workplaces that range from office buildings to retail stores to mines, coal mine, and the idea is that they have a few 100,000 places, and they only have resources or inspectors to inspect a small number. We're all familiar with those types of problems. How do we select those few hundred, few thousand places? Do we select them to maximize violations that we find? Well, in which case, it might be very efficient, but does it actually reduce or deter people from violating, or do we maximize some other deterrence metric that we actually care about? So Chile and workplace safety is one example. Environmental, so this is some work with the Environmental Protection Agency in the US, where they again have to inspect a few 100,000 facilities that dispose hazardous waste, and to make sure that they're not doing that in a way that's going into the water or affecting people. Same idea, a few 100,000 places, they can only inspect a few thousand. How do they do that? To rental housing properties that need the same type of inspection, of different types of inspection, but again, limited resources. So it's another class of projects where we have to kind of make these decisions around how do we allocate these resources and for what societal goals that we care about. One last example I want to give before we switch topics, and this is some work we were doing in Jakarta in Indonesia. And it's not about sort of inspections or predictions, it's really about understanding the state of the world, kind of detection better when sort of you have don't have access to structured information or structured data. Right? So this is Jakarta has about a few thousand traffic deaths every year, so pretty bad. And so the city there, in order to sort of figure out what's going on, what are the root causes of some of these accidents, what they could do, well, they decided to install a few thousand cameras in the city. And after a couple of years of that, they came to us and said, well, we put in a few thousand cameras, and now we have videos from a couple of years from a few thousand cameras, and we don't know what to do with it. And so what they were kind of interested in is taking that video stream for all these different cameras and detecting kind of events like these, not to really do prediction, but really to kind of figure out what are some of the underlying factors that are causing accidents to happen. So things like, going from videos to sort of a structured stream of rows and columns. Let's say it was a non-vehicle using the roadways. In this case, it's a food cart vendor at this time at this place, or an overloaded motorcycle. That's pretty normal. Or pedestrians walking through traffic, or cars going in the wrong direction. And if we could sort of convert those videos to these spreadsheets with these events at specific times in specific places, they could then they could do that analysis of what's happening downstream. Are there certain things causing those accidents, and what can they do to prevent those things? And so the analysis there was really going from the stream to first trying to figure out what are the things in there: cars, rickshaws, motorcycles, buses. And while that sounds easy, if we've seen all the overhyped videos of people doing image analysis, it turns out most of those systems are built for US traffic, and so much so that if you actually run them even in London, they won't detect the buses in London because the shape is totally off. So we had to kind of look at how do we detect these types of things that are not the standard things that people build these systems for, which again raises a lot of these issues around what are these tools in AI, who are these built by and who are these built for, right? The second idea was sort of, once we've detected these objects, which direction are they moving in? And then third was, where are they? Are they on the street? Are they on the sidewalk? Are they on which side of the street? And putting it all together, we were able to sort of find things like, here's an example, right, where this is a two-way street. As you can see, cars are coming repeatedly, from the other direction, and that causes sort of potential things downstream. And so in this case, the intervention really was, trying to put a divider in the street so that people are not able to go around and put other people at risk who are going to be downstream of this. So again, the idea here was less, make these predictions or do the inspections, but really more about how do we provide people with more information in a more structured way so that they can make better, they can themselves do better analysis and make better decisions around those things. So there are many, more projects there are more details about these projects at this URL if people are interested, and more details about these projects as well. The kind of stepping back a little bit, right? In a lot of these projects, the kind of stepping back, a lot of these projects kind of do three things, right? One is we're trying to kind of understand human behavior in many cases. So what types of people are at risk of, what types of people have been going back to jail, and what are kind of some of their things that we can try to understand, that says, so that it's not just understanding the people who are going back to jail, but also understanding the context and the society and the criminal justice system and the health system that is how to think about sort of, what's happening in that context, and so the second piece there is then predicting what's going to happen to these people in the future. And then third piece is, again, as I said, it's not about predicting, it's about changing the outcome, so that how do we connect them with the resources, the mental health resources or the lead inspections, to connect those together in order to achieve, higher level goals. So there's sort of a few other things in common across these projects, right? One of them is that none of those systems are making autonomous decisions. They're not automated decision-making systems, or even recommending systems like, advertising systems or trading systems. They're making important decisions about people's lives. They're making decisions around kids' health and lead poisoning and people's future outcomes and their risk of going to jail, or protecting innocent civilians from police misconduct. And there's a person in the loop in all of these cases that's being provided additional information to hopefully make better decisions. And in that case, the goal of the machine learning, the AI, pick your favorite buzzword, is to really support that person in achieving kind of larger societal goals, which I'll get to in a minute. The second thing that's happening in all of these cases, which is really unfortunate, is that all of those projects are allocating limited resources, right? And if the resources weren't limited to only help certain number of kids that we can prevent, or a certain number of people from going back and provide them mental health services, or providing only a small number of students with the after school or support programs, then we wouldn't need to do any analysis on the front end, on at least restricting the set of students we prioritize. We would still use data and machine learning and all those things to possibly evaluate the impact, to figure out the best intervention to give them, but we wouldn't be trying to use them to reduce the number of people we should prioritize, because we shouldn't have those limited. But that's kind of the current system current society we unfortunately live in. The third thing that's kind of implicit in all of those is that there are a lot of different goals we could be designing those systems for, right? So if we take all those different projects, you can imagine, in the case of the jail recidivism, if my goal was efficiency, what I might want to do is say, well, I have limited resources. How do I use those resources to help as many people as possible? And if I design a system to achieve that, most likely it's going to, if I want to maximize the number of people I help, it's going to pick people possibly who are easiest to help or cheapest to help, and will leave behind people who are much more difficult or harder to help, or more expensive to help. And so focusing on efficiency at that point is likely to lead to inequities. In the recidivism example, in the lead poisoning example, in the schools outcome example, in pretty much anything, that there's a tension there of, if I want to help as many people as possible, I'm going to prioritize people that are cheapest to help and leaving behind people that are harder. And so the question here becomes, how do I balance these different goals? And how do I even elicit or elaborate these goals, and who should be involved in coming up with these? Is it the people building it, Definitely not. Is it the people who are being affected by it? Is it the people who are actually using it? Or is a society as a whole? Is the society in these things? And those are not going to be AI and machine learning questions. And if you look in the Q&A, some people are getting pretty depressed that I'm not talking about the latest neural networks that was developed that can't answer these questions, but instead I'm talking about some of the more underlying systemic issues that we're using AI to tackle. But AI is sort of a tool that supports people as opposed to this autonomous thing that's going to fix all of these problems, right? And so thinking about these goals, the larger question that we're sort of thinking about across these projects is how do we develop human AI collaborative systems that can help make decisions that lead to fair and equitable outcomes, right? And so the key here is again, not autonomous, but collaborative systems that are helping us make decisions. And then we're focusing on designing these systems so that they lead to fair and equitable outcomes. And again, the one piece that I'm not going to go into detail, but I sort of mentioned because it's an important piece, is that if we're building these systems to collaborate with people and interact with people and support people who are making decisions, whether it's caseworkers in the criminal justice case or mental health workers or inspectors or after school program counselors, it has to be designed for consumption by people and not consumption by other machines or algorithms, right? And so we need these systems to be both explainable, interpretable, for a lot of different reasons. And here are sort of like the 5 specific reasons we end up finding that keep coming back again as 3 to 5 different use cases for why we want these AI systems to be explainable. One is just for people like us who are building them. We need them to be understandable, to just even sanity check and debug the system that we're building. Another one is a lot of these systems are not, well, none of these systems are 100% accurate. Right? So when they recommend somebody to be prioritized for mental health outreach program, for example, there might be only, of all the people they recommend, it might be only right 40% of the time, because and they're still useful. They're still better than a lot of, better than what people do today, better than, a lot of other things, but they're wrong a lot of the time. And by trying to understand why the system is recommending that person, why the system is making that prediction, that can lead to the human in the middle overriding when the human thinks it's wrong, and reinforcing the correct decisions and overriding the wrong ones, and to actually improve the outcomes, or to create an increased trust and adoption of these systems when they are correct. Or in many cases, the goal in a lot of these cases is not really prediction. The goal often is the goal is to change the outcome. That they're one of many interventions available. So for working with an employment agency where they are interested in trying to figure out if somebody is coming in, an unemployed person, what programs do I connect them with that increase their chances of getting employed in the next 3 months, 6 months, 12 months? In which case, an explanation for why they're high risk to be long-term unemployed might indicate which one of the many intervention programs they should be assigned to. And then in many cases, a lot of laws are already asking for recourse. So if you're denied a loan or a criminal justice outcome that denied bail, for example, you're being asked, the system is being asked, you have to be able to explain the decision and provide them a way to change certain things that will then not only change the prediction, but also change the decision that's made using the system. And for that, we need a lot of these, we need these systems to be able to provide that. The one thing that's sort of important to kind of keep in mind is that in all of these cases, they're all very different use cases. So there's no generic explainable AI or interpretable system. Each of these are very different things that we have to kind of design specific methods and tools for. The other thing that's sort of across all of these is when we sort of think about, again, of using AI to make things, fair and equitable, often we end up getting stuck on kind of making the AI system or the machine learning model fair, which is kind of this tiny piece in the middle that, there's a bunch of things around it, and at least that the work that we've been focusing on is, which is not very deep. It's that instead of focusing on this little piece that's the machine learning model, the goal should be making the overall system and outcomes fair rather than making the machine learning model fair. Because you could have the machine learning system be perfectly fair, and the overall systems be unfair. And you can have the machine learning system be unfair, the model, and the whole system be fair. So the model being fair is neither necessary nor sufficient for the whole system to be fair. And the reason for kind of thinking about, I think stepping back on this is to sort of see, well, what are the underlying root causes of bias and outcomes when we're using some different types of data-driven systems? And the first source really, unfortunately, is the world, right? We often talk about the data and the machine learning model and all these things, but a lot of the starting point is that the world is unfortunately biased. The world is unfortunately racist and sexist, and the world generates events and outcomes and behaviors that have that bias encoded in there. And that's a problem, right? And so you can have perfect data capture. You can have perfect data, which there's no such thing as perfect data. Of course, any of us who work with data, data is always bad. And the question is, is it useful enough to do some of these things that we're trying to do? But even if you had perfect data, it would still capture the biases of the world, unfortunately. And once we've sort of captured the data, when we're starting to do something with this data, we make a lot of choices and decisions. We choose certain data sources. We don't have access to certain data. There are a lot of sort of noise in capturing data, so we lose certain things, and so a lot of sort of different things happen. And sometimes we assume social media is the entire world and assume reality, or we don't measure things right, or we have things so the example I was giving around the police departments and predicting officers at risk of doing horrible things. Well, in that case, the data that's coming in, who is deciding what is horrible in the past is an internal affairs team inside the police department that looks at every incident and says justified, unjustified, justified, unjustified. So if you have a horribly corrupt police department that thinks everything is justified, the machine learning system isn't magically going to figure out unjustified things. It's going to kind of learn from that biased world or the biased data. And it's going to even not just encode it, but it's going to make it worse. Most likely, it's going to amplify that. It's going to then create this cycle of making things much worse for the people. They're already being abused by the police. So once that move on, then we start building the machine learning, the AI system, and we make a lot of design choices, and we introduce a lot of biases, right? Even if the world was fine and the data was fine, we make a lot of choices as the people developing this system. We choose how to create different variables or features or predictors, or we choose, if we have something missing, how do we fill that information in? So for example, a common thing people do is take data, and if I have some information missing about somebody, let's say, I have people from different countries in my data, and I have, their, let's say, height missing. Well, what typically people would do is just take the mean height of everybody in the data. So the data is 80% people from, let's say, Netherlands, and you're missing data about other people on the height. If you just take the mean, you're going to make everybody look much more like people from Netherlands, which might be good in many cases, but it might not accurately reflect who they are. And then it has downstream impacts and different types of biases. So there's a lot of simple things that we do in designing these systems that incorporate, often unintentionally, these types of biases. And then let's say we have everything here good, right? The world is perfect. The data is perfect, never is. The AI pipeline is perfect, it never is. Even if everything happens, then the actions we're taking after these systems that the systems are informing, they might be biased, right? So for example, the lead poisoning example I was giving, we spend a lot of time designing these systems to be fair, but then we noticed that the next step was we generate a list of kids at high risk of lead poisoning. The health department started calling them to make appointments for home inspections. We found that it turned out that the initial phone calls were happening in English. So the system, the technical system was fair, but the intervention was starting with a phone call in English, which means that anybody who couldn't speak English was being left behind, right? So a perfect system up to now still results in totally inequitable outcomes because the actions are biased. And so all of these things kind of together, the idea is to be able to focus on the entire system to understand and deal with the disparities rather than focusing on just one piece. Because again, our goal is sort of at the outcomes level and not making the AI system fair, because who cares if the AI system is fair or not? And so the type of approach we take is sort of, we start with saying, well, how do we define what we want? Because fairness or equity, or those are all buzzwords that don't really mean anything specific. So what's in a specific context, what does it mean for a system to achieve fairness or equity? Who should be involved in designing those goals? How do we come up with those? How do we validate those? Once we have that figured out to some extent, then how do we measure and detect bias both in the world, but also in these types of systems? How do we understand the root causes of them, the things that I talked about? How do we improve, at first step at least, the AI system that we've built, if we can, as much as we can? It's most likely not going to be perfectly fair. So then how do we design our interventions and actions to mitigate that impact? As opposed to just assuming that that's the impact that's there, well, we can adjust the outcomes, the interventions we do. And then how do we monitor and evaluate the system so that it continues to sort of achieve those goals? So the overall kind of idea behind the way we've built these systems is that first step is to figure out, what do we want these systems to do? What are the values we want these systems to have? How do we build it so that they achieve those values? And then how do we implement them and monitor them and evaluate them so that they continue to achieve those values that they were intended to build? And if we start with kind of thinking about what does it mean to be fair and equitable, there are a large number of metrics that people who are much better at those things have come up with. And the good and bad of those is we have a lot of different metrics we can call fairness and bias metrics. But it's not clear which ones we care about and which ones are more important and which ones should we care about. And in many cases, a lot of these things are not, concrete, that these metrics are concrete, mathematical, have definitions, but in society, it's not clear what some of these things actually mean and what they lead to. And there's sort of things like, well, do we want to allocate equal resources to every group? Well, maybe, but only if those groups have equal needs. Or do we want to allocate resource proportional need? Well, yes, but what if we disproportionately miss people of a certain group who needed that, versus what if we make sure we don't want to have disproportionate false positives from a particular group? And all those seem like, yeah, we want all of those. But we're not going to be able to get all of those. And so one of the things that's been happening in this field is people have been proposing these metrics, and then people have been doing some, interesting work saying, well, we can't have all of these. If you want this, you can't have that. And that while that's true on the technical side, on the policy side, one way that this is being interpreted is, so if you want to be fair, machine learning or AI can't be fair. It can't give you this and this. And so we shouldn't use machine learning or AI. And what's sort of being missed is that no, these things are not about machine learning. They're about any human decision-making system. If you want this, you can't have that, but any decision-making system. It's not about a machine or a computer or AI or ML. It's just inherently true. And that's true for a lot of these questions that are being asked in kind of the intersection of ethics and machine learning and fairness. Is those questions are not new at all. They're the same questions that have been asked for many hundreds and thousands of years, except some of those questions have become more sort of urgently important because in the old days, there was a lot of variance in how different individual humans made decisions. And that variance kind of helped us in some cases to not be totally horrible. And the risk here is that the systems and algorithms that are coming up are going to be designed by a handful of organizations and people. And they're going to be making some of those decisions for us. and consolidate them into, one or two or three systems, for example, that might make all criminal justice decisions. And so the risk becomes much higher. Now, the opportunity is also high. If those systems are good and consistent and do what we want them to do, then they can improve over the current horrible criminal justice world, right, where we make pretty bad decisions. But at the same time, the risk is also high, because if we get them wrong, then they can make things much worse, because we don't have that natural variance that humans making small decisions and somewhat independently do. Right, so that's kind of the first piece. Like, how do we even figure out what we care about? And so one of the things we came up with is called we call a fairness tree, and it's a kind of a simple guidelines for policymakers to sort of think about, like, what metrics should they care about, and it's very much a function of what do you want to do with the system, right? So a generic system that's going to, for example, take the thing that's, example from the jail recidivism example, right? We've seen horrible uses of those types of systems. We've seen uses for predictive policing, for example, which should not be used in any way ever, because the intervention in that case is punitive. You're putting, you're allocating more police resources, which there's no evidence is going to actually help anyone, and leads to much worse outcomes anyway. But in that case, that your intervention is punitive, right? So a false positive in that case is much worse than a false negative. So if you if you flag somebody who, that's going to be much worse. In the case of where we're using it to predict incarceration and then provide mental health services, or provide, lead inspections or after school programs, missing somebody is much worse than incorrectly including somebody in most cases. And so then we care about sort of, not having disproportionate people being missed versus disproportionate people being flagged incorrectly. And so not going to go into detail, but sort of it gives policymakers a way to kind of think about which of these things are more important and which ones to prioritize. The next thing that we have is that once we've figured out what we care about, and working with different stakeholders and the community members, the people being impacted, trying to come up with those set of metrics, we've got a tool we built to kind of that audits the systems for the fairness and bias, and sort of says, well, this group, according to this metric, it has 3 times as much bias than this other group. So it allows people to audit their predictions and their models, and ideally sort of release those audits publicly before they're able to use these types of systems, whether they're buying them or using consultants or building them internally. These types of audits, the idea is to be able to release those audit results publicly and justify why they're being used. Now, these audits also have a lot of nuances and caveats. The biggest one is that if we're using this audit to sort of figure out disproportionate errors, well, the errors are based on the ground truth that we have, and that ground truth may not be accurate in many cases. Take the police example again. So that's something that we should kind of keep that in mind. And then the last piece is sort of like, how do we think about, when we're given these types of approaches, how do we think about developing our AI system, right? So before, we would sort of design a bunch of these different systems and say, oh, the yellow one is the best one, let's pick that one to use. And what we're sort of doing is saying, well, no, it's not as simple as that. We've got sort of this, at least one other dimension, if not many others. And now we've got sort of this green one that might be worth, giving up this much in performance to get reduction in that bias. And we're finding sort of, that type of work is not necessarily trivial, because it sort of leads to, so here's a kind of example of like, I'm going to skip through some of these things. Here's an example of another project around criminal justice we were doing, which is similar to the first example. Again, limited resources, and the system they asked us to build, the idea was to sort of provide them a list of, again, a small number of people who might be high risk of, again, being arrested, so that they could prioritize them for different diversion and social service programs. And the first system that we built for them was the one that was sort of, in some ways, off-the-shelf machine learning AI that's designed to be as accurate as possible. And accuracy really becomes a synonym in these cases for efficiency. So the standard machine learning, if you just use it out of the box, is going to give you a system that's accurate, which means it doesn't care about different groups of people. It's going to just get as many decisions right as possible. But that again means kind of helping the most number of people framing. And so that system we designed was, 73% accurate. Off the 150 people it flagged, 73% were actually going to come back. So their resources were allocated efficiently. But it was more accurate for white people than Hispanic people. And this is South Los Angeles. And you look at the criminal justice system, the Hispanic people had a higher recidivism rate than white people. So using the system would have helped both groups. It would have reduced recidivism rate for both groups because it's helping both. But because it would have been more accurate for white than Hispanic, it would have reduced the white recidivism rate faster than Hispanic and would have increased already existing disparities. So we gave them option number 2, which was designing for equality, which was about the same, like 2% less accurate, less efficient, but it was equally accurate for both. And so what that did was it reduced recidivism rate for both groups, but it didn't increase disparities, but it also didn't decrease disparities. It basically preserved the status quo. So we gave them option number 3, which was about the same cost as number 2, and that was focused on equity, and that was more accurate for Hispanic people than white. And the idea was that if you do that, you start reducing that disparity and get to equal recidivism rate downstream, which is sort of getting you towards equity. So in the back, there was a lot of math and algorithms to sort of figure out how do we actually achieve those? How do we do those trade-offs? How do we design these systems? But the idea here was that reasoning at the top to the policymaker is giving them a policy menu that kind of tells them not all the math and not all the algorithms, but really about here's a menu. If you care about efficiency, here's how much you're going to gain, and here's the outcome: increased disparity. If you want to preserve the status quo, here's option number 2. If you care about equity, here's number 3, and they all cost the same pretty much. So they decided to go to number 3, but it really required us kind of a mapping from a lot of those metrics that we talked about to really kind of the policy outcomes in order to sort of achieve these types of goals. And I think we've done that in a few different projects over time now, and we're finding that we don't actually have to sacrifice accuracy necessarily in order to get fairness, because in the AI world, there's sort of a common assumption people make is that you have this trade-off between accuracy and fairness, and you have to decide where you want to be. And it turns out in practice, not theoretically, but in practice, for these types of problems, we've repeatedly found that we don't have to sacrifice accuracy in order to get fairness. But that only happens if we deliberately and explicitly these systems to achieve equity and fairness. If we just build them, they're not going to be accurate and fair. But if you sort of explicitly build them to be fair, and there's I'm happy to point to some papers that we've published recently that sort of empirically show that type of stuff. So I know I've gone a little bit longer than I intended to, but just to kind of summarize, right? Like we've sort of seen a lot of these buzzwords, machine learning and AI, giving us ways to be more personalized. And that's also true in the policy and government world, is that they can help us design more personalized policies. But up to fairly recently, they've really been used to be more efficient, running governments more efficiently and making the best use of resources, not necessarily to be more equitable. And I think they have a huge potential to be more equitable. And there are a lot of people sort of trying to develop these both methodologies as well as tools that allow us to sort of get there. Second thing is that we often sort of, when we're building these AI systems, we sort of think of our only goal is to be as correct as possible, but there's no definition of correct. We arbitrarily come up with a definition of correct, which says every single data point is equal. Well, that's not true in the real world. So why are we treating it that way? Each data point is not a data point. It's a person. It's a kid, and we might want to think about we definitely should think about sort of fairness and equity as kind of the primary goals and metrics, and not as by the way, at the end, I want to check for some of these things. You should be kind of designing for that. And then again, a focus should really be on how do we make the overall system and outcomes fair, and the system meaning, the entire, where the data is coming from, what the technical system we're building, and then the human that's part of the system that's making some of those decisions. How do we make the whole thing fair instead of over focusing on the machine learning model itself? So just some plugs for things in case people, are interested. We actually just released this. A lot of these projects started from a summer program that I run, summer in the US, May, June, July, August, that we just actually opened up applications for that program. So if people are interested in spending the summer in different capacities, both as student fellows, but also it's a paid summer internship program, but also as mentors and also if you're from government agencies or nonprofits, as project partners. Yeah, some resources that I talked about, the bias type things as well. And then, so happy to take questions. And I'm happy to stay a little bit longer since I did go a little bit longer as well. So.
Thank you, Ray. That was really fascinating, thought-provoking, compelling. I really appreciate you sharing all of these examples, and we've got some great questions that I'd like, if you're willing, to spend some time going through some of these questions from our audience. So thank you very much. I'd like to start actually with a comment and a question here that's come in from David, because I think if you think about our audience here, we probably have a lot of AI, machine learning practitioners, people who are used to thinking about AI in the context of, I'm going to design and build an algorithm. But as you've clearly articulated, the application of the technology actually applies to real world, societal, human-centric questions, challenges, and really societal issues for us to fix. And so the reality here is that the beneficial use of machine learning and AI means we need to have, as you've clearly demonstrated, this deep, meaningful appreciation of the social systems to which we can apply these technologies. And so what do you think we should be doing, right? To what extent should we be encouraging our practitioners truly to understand these social systems and application contexts? And if you think about, you just mentioned your summer school, the dynamics of what you've observed of the practitioners who come in to learn about AI and machine learning, how do we strike this balance around the computer scientist becoming the social scientist, and your experiences or recommendations for how we should be thinking about this?
Yeah, I mean, that's a really good, but also it's easy to tell you. So I think the answer is easy to say, but very hard to actually implement, right? Given our current system. So, and I think the other thing, so I'll get to that, but I think the other thing is that a lot of these fields are very new, right? Like we haven't really been doing these types of things in real systems for very long. Yes, people were doing a lot of math and people were doing a lot of statistics, and a lot of this work was happening inside, universities and labs, but it hasn't been very long where these systems have been deployed and been used, and we still don't know the outcomes of many of these types of things, either because they're happening in large companies or they haven't been there long enough. And so I think it's not like any other field that's sort of a component of everything else, that has to understand those things that come before and the things that come after. And I think, at least in my view, the starting place for doing that is during training, right? Exposing people to other disciplines, as opposed to telling them that they are uniquely self-sufficient to solve any problem in the world. Some disciplines do that really, really badly. I mean, econ is a really good example, right? Econ tells their students that they're uniquely qualified to do everything. AI is unfortunately getting there. But I think, no field individually is self-sufficient to solve any complete problem. We kind of need to embed, and at least the experiences I had from my summer program were interesting, because we would try to put these things together, with these students together in the same team, from computer science, from sociology, from public policy, from engineering. And the first few weeks of that were bumpy, because they weren't quite sure of the value of some of the other people on the team, or they were being pigeonholed that, oh, you're a social scientist, so you must understand the domain really well. Like, no, I know how to deal with data. or you're a computer scientist, so you must not really understand people very much or care about, the context of the data. And so there were these sort of caricatures and stereotypes that people had built because they'd never been in the same in the same classroom, let alone working on a project together. So I think that's probably the kind of the biggest way that I think we want to expose people to other. But then the second piece is to kind of embed them into the problem and in the communities where these problems are being solved, as opposed to kind of solving them. It's not even clear what solving them means, right? But even to understand the problem before you start solving some of those. So and again, we don't do a perfect job. We sort of try to attempt, in these types of projects, try to send students to spend some time with the communities, with the people who are collecting the data and or intervening on, or consuming their results. Try to understand what's, where it's coming from, what are some of the nuances there, and yeah. So I think that's kind of the short, but still much longer than we have time for answer.
So there are several questions about the thesis you presented here around fairness, equitability, and bias. And I really liked your comments around, we really need to focus not just on making a model fair, but by making the overall system fair. So Emil asks a question around, in the context of these demographics that you were describing, you used the Netherlands example of perhaps tall people, where you have a diversity in demographics. How do you respond to that? Do you just build new models? And if your most critical person in some of your examples around lead poisoning or criminal justice, if there is a demographic, perhaps whose group size reduces to even 1, how do you deal with some of those differences in demographic diversity?
Yeah, and I think that's where the solution isn't necessarily a technical solution, right? So we do as much as possible we can do technically, which is we sort of try a lot of different approaches to see which one reduces the bias in our systems the most, right? And again, one of the things is that the field is relatively immature right now. So there are a lot of methods that have been proposed. Most of them haven't been tested on any real problem. And so actually we just tested a few of these over the last year on several of our projects. And we found that most of the things that were proposed, they gave very inconsistent results in terms of kind of reducing bias. And it wasn't surprising because they weren't built for specific needs. They were sort of built as general purpose abstract systems or methods, and they rarely sort of are going to work. So I think right now a lot of the field is kind of detached from real use cases and real problems. But so we try a lot of different approaches to sort of see, including the ones that Emil is asking about, right? Is, well, we can make a new model for each group, but that new model, as you said, if it's one person, you can't really build a model from that one person, right? So we try to kind of reduce as much as possible we can do technically. But then the next piece is, okay, how are we adjusting our interventions? So if we know that we don't have enough information about that group, or we're missing that group at a much higher rate, well, we don't want to build a separate model on them because we can't, but we can certainly design separate set of interventions for them, right? Or over allocate resources for them so that we know that we're going to miss them disproportionately. How do we adjust the allocation of resources and the type of resources to try to ensure that the outcomes for them don't suffer because our model is bad? That's our fault that the model is bad. It's not their fault. So I think it's that coupling of how much can we do by getting better data, how much can we do by kind of adjusting the analysis that we do, the models that we built, and then how much can we do at the end with the interventions. All of those things are kind of what come into doing that.
Yeah, thanks. And so by extension, Iman asks a question around, should we be thinking about being more data-centric versus model-centric, right? We talk about machine learning models all the time, but should we really be thinking data-centric versus model-centric? And does it change the way we think about fairness and equity?
Yeah, I mean, I think, I don't want to use the cliche, human-centric, right? Or, but I would sort of say, we should be sort of human equity-centric, right? Because again, data is, we can fix the data, but that doesn't mean that the data will only, fixed data only captures what actually happened in the world. And if what happened in the world was racist or sexist or biased in other ways, then perfect data will capture that. And then our model will, at a minimum, replicate, worst case, more likely amplify that. So I think we kind of have to go sort of building a model of the world and seeing, and that's where a lot of this has been done for a long time by fields that are not doing computer science. And, they're trying to understand the building a model of the world, and then building a model of the data generation process, data collection process. And again, a lot of fields have been doing that for a long time. And then looking at the modeling world, AI world, and saying, well, how does that world generating that data, how do we use that? Also knowing that how it's going to be used in the future. And so then thinking the next step. So I think it's really I don't know if it's simple as like taking just one of those views. I think we have to sort of take each of those views, and then I'm just making things infinitely more complicated, right? And then you have to kind of think about how they interact. So it's not simple, but I think it sort of then starts getting towards that's where we need all the different disciplines to come together and really do this together, rather than sort of say, well, that's your problem. You're building the AI models, or you're intervening using these public health interventions. So you figure out how to deal with it.
Thanks. And so I'm going to shift now just to a couple more questions before we wrap up around the implications. So one of our audience comments that clearly AI can be very useful in early detection of issues, as you've identified with some of your examples. But to scale and to end up with sustainable solutions, right? Not just one police department, but all police departments as an example, probably requires enacting legislation or government policy. And obviously at Carnegie Mellon, you've had a strong focus on public policy. But what role does AI play there? Will AI cause us to change legislation, influence legislation, or what is the role in legislation in order for us to get to these sustainable solutions that you talk about?
Yeah, absolutely, right? Because a lot of the work, if this is all that happened, we would help a few people in one place, and even then we wouldn't really fix the systemic underlying issues, we'd just fix the kind of the at the end. So that's not the intention. I think exactly the intention is to then feed these back into change in policy. And I think one is that, a lot of the policymakers today, there isn't much of a collaboration happening. Those two worlds don't often come together. If you've seen any of the US congressional hearings recently on the politicians interrogating some of the tech people, there's just there's lots of blame to go on both sides for a lot of those things, but it's sort of like we haven't quite figured out sort of how to do that effectively, right? So, and that's kind of like what we're trying to do, is like how do we train both policymakers in these types of things, and train the AI people to be exposed and understand the nuances, because if we actually want to have impact, it's going to have to be through policy. That being said, I think some of the things that are happening now, so some examples I was giving, the last example I had around criminal justice and sort of reducing the disparities in recidivism. Well, today we don't have, we have the technical capability to do this, but we actually can't do it legally. So in the US, you cannot use race explicitly to make these criminal justice decisions. Now, maybe judges can do it implicitly in their head because they don't write it down, but the system that I'm describing technically is illegal because it's using race to reverse the discrimination that's been going on, to take the people who've been discriminated against for a long time and try to reverse that so that we can reduce those disparities. That is illegal. So the law doesn't allow some of these things, and the question is, how do we bring those two things together? How do we sort of figure out, is it something we shouldn't be allowed to do? Is it something we should be allowed to do? And then if we should be allowed to do, how do we change the law to sort of support these types of interventions that are reversing some of the discrimination that's been happening? And so there's a kind of a strong interplay, but again, that involves people from, policy, law, AI sort of coming together to really understand some of these things, but then getting them to be implemented at a law and policy level to really have that impact. And it's starting to, at least those conversations are starting to happen, and not just in the US, in other, Australia included. Like those conversations are at the early stages, but at least they're happening.
Thanks. So several other comments here around people being very pleased to hear this focus on social impact statements. One of the questions here, or one of the comments here was around, in essence, you mentioned a model here that said, what we're doing is we're understanding the world, we're predicting the world, and then we're looking at how to influence and intervene in some of your examples. So it's a focus on assistance and support rather than violence or punitive measures in that decision matrix you showed. So this notion of bringing the human and AI collaborative system together does enable us to look at a much broader view of multiple systems. So how do we bring government and legislation into those discussions to look at that overall value of human decision maker and AI system recommender? And so it's not just human and machine, it's really individual, legislator, government, and machine in a loop. And how do we pull that together? And there was another related question around, can we really look at, from Rosamund, can we really look at analyzing and intervening conflict between states or disparate points of view, or potentially conflict even internally within government? How do we bring that broader picture together?
Wow, I'll wait for a minute for the second one. On the first one, I think that there's sort of a couple of directions to think about, right? One is often when today, most of the examples I gave, we have sort of existing human systems for kind of tackling them. There are people who are doing that manually, and it turns out they're not doing that very well, neither in sort of efficiency and especially not in equity. So when we actually audit the human systems, they're pretty bad. And that's the bias in the world, right? It's unfortunately. And so I think one thing that happens when we build AI systems, often the first thing that people want to do is they go, well, but it's biased. Like, well, yes, it could be. But how does it compare to your existing system? Is it more or less biased? Now, even if it was less biased, the risk again is that bias can easily amplify, and the thing I was talking about of not having that variance, because humans might be making somewhat independent decisions, and lots of them, like each judge making a separate decision around the country versus 3 systems making all the decisions. So it's still risky there, but I think it's important to kind of think about compared to what, right? It's not compared to perfection, but it's compared to something else that's ideally sort of starting with what the human is doing. And again, the goal is not to have the computer do things by itself. Like we can measure how well the computer does it, but that's never gonna, for most of these decisions, it's not what we're going for. So today it's the human, then we sort of add the computer and we put them together and we sort of see how well does that system do. And in many cases, in some cases it does better, in some cases it does worse. And in other cases it does exactly the same as it was doing before. And we've seen all of those. Because when you actually run real trials with coupling them together, we find that, when the human is in some cases pretty useless and they just randomly, agree with certain things and randomly disagree with other things. In some cases, the human's actually really good. And they're able to kind of tease apart the things that the computer might be right about and agree with those and vice versa. And in some cases, the human's really bad, so they do the reverse of what should be done. But the second point I think you were making was that when we sort of talk about human in the loop, I sort of think about there's lots of humans in lots of different loops, right? That there's sort of that policymaker to the society loop, right? And then in the middle, there's the machine here. But then there's the loop of sort of different people who are building the system. Like we are in that loop. We're making certain decisions about the system and it's sort of coming back. Then there are the people who are acting on the recommendations of these systems, the unemployment counselors, the caseworkers, the school teachers, and then there are the people who are actually being affected by the decisions made and the actions taken, right? So we've got at least four groups of people in sort of different loops, all connected. And today it's not clear who's accountable for what piece, who's involved in what piece, who's designing, what decisions are being made by the system developer versus the person who's being impacted versus the policymaker. Who understands this? It's a mess, right? And I think that needs to be a little bit more organized and much more inclusive, and not full of sort of technical buzzwords so that it intimidates people when you try to bring them in. And I think that's something we have to do a lot of work on.
Thank you. This has been a fascinating conversation, Rayid. I could continue for hours in this conversation, but I do want to be sensitive to the time and the generosity of your time spending today with us. So thank you very much for leading this lecture today in our Monash Prato Dialogue Lecture Series. It's been an absolute pleasure to host you.
No, thank you very much. And for anyone who has, I know there's some unanswered questions, please feel free to email me if you had other questions. Happy to chat about these things. My email was on my slides. That's just my first name @cmu.edu. So happy to answer those offline. Thanks for having me here.
Thank you very much. Before we close the entire proceedings here, I'd like to invite our audience to join us at our next lecture in this series, which will be on the 1st of December Australia time, where we'll be hosting Professor Milind Tambe from Harvard University. And Professor Tambe will be giving a lecture on, again, artificial intelligence for social impact, but from a different angle. So we really encourage you to join us in our next event and to stay engaged with the Monash Data Futures Institute to receive invitations to attend our upcoming events. We do encourage you to follow us on social media, both LinkedIn and Twitter, and you can join our mailing list to receive information about our programs and our events by signing up for our affiliation program on our website. Thank you all today for joining us. You've been a wonderful audience, and thank you for staying on for a little longer as we engaged in some of this dialogue around societal impact. It's really been a fascinating discussion. I look forward to seeing you all again in our future Monash Prato Dialogue lecture series, and join in with us in these valuable and often provocative discussions. Rayid, thank you again for joining us today. It's been a great event, and hopefully just the first of many conversations that we'll be having around the impact of data science and AI for social good. Thanks for joining us today, and goodbye.
Thank you.